Measures of variation are ways to describe the distribution or dispersion of data. More simply, it shows how far apart data points are from each other. Here in this video, I'm going to show you the formulas that you can use to compute them, but I'm going to show you a much easier way to do it by using our TI-83 or 84 calculator. So first we're going to go over the first measure of variation, which is the range. And it is simple. It's just the difference between the maximum data value and the minimum data value. So just max minus min. So if you're given a set of data values, let's say this set right here, and we want to find the range. Well, I've kind of color coded it already. In red is the minimum, which is 34, and in green is the max, 73. So we just subtract the two and we get 39. But what if you have a bunch of data values and you don't want to start sifting through all of them trying to find the max and the min? Well, there's an easy way to do it, and that is with our calculator. So that's what we're going to do. So we take our calculator and we're going to input all of our values into a list. So we go to stat and then one edit, and we're going to put all our values in L1, which has already been done. So we can just input all 9 of our data values in. And once we're done, we go to the next part, which is stat again. Click over to calc, and we want to do one var stats. So we have one var stats, and if you have multiple lists, you need to specify which one, but if you only have one list, you can press enter. But if you want to make sure to know how to do it, to input the list you want specifically, just press second and whatever numbered list you have. So we used L1, so we're going to press 1. So second 1 to get L1. It'll think about it, and it gives us a bunch of statistical values. Now to find the max and the min, all you got to do is see how the arrow is pointing down. Just scroll down until you get to your min, which is 34, and your max, which is 73. So it will tell you if you don't want to look through all your data values. Next is the sample standard deviation, and its notation is a lowercase s. And it is just the average deviation of the sample values. It is the sample values from the mean. And you actually have two formulas you can use. You can use the first one here, or you can use the second one here. Both will give you the same result, just a matter of preference. So we use x bar for the sample mean, and we use little n for the sample size. And this big capital E is a Greek letter, just means summation. But again, we're going to use our calculator for this. So we've already gone to one var stats, so we're right where we need to be, except we just need to scroll back up. And right here, we have Sx, which is the sample standard deviation of 13.56568383. So there we go. So S equals 13.565683. And I'll just go this far, because I want to round it to 2 decimals, so 6 decimals deep is enough. So I'll say that my sample standard deviation is 13.57. And it's as simple as that to get the sample standard deviation from your calculator. So let's go on to the next one. This time it's the population standard deviation, and it's used, it's notated as the Greek letter for sigma. It's the lowercase sigma, and it's just the average deviation of the population of values from the mean. And its formula is fairly similar to the one above, the first one above, except instead of x bar we have mu, and instead of little n we have capital N. But again, we're not going to use the formula, but you're welcome to if you want to. We're going to use our calculator, which again, it's already been done for us. Right here, sigma x. That is the population standard deviation. And so I'm going to just copy it down. So sigma is going to be equal 12.789849. But I don't want the whole thing, so I'm going to round it. So I'm going to say that sigma is 12.79 to 2 decimal places. And that is the population standard deviation. Next, we have the sample variance. And it's really nice because it's even less work. All we have to know is that the sample variance, notated as s squared, just means that it's the square of the sample standard deviation. So take your sample standard deviation and square it. But you need to be careful. If you try and square the rounded answer that we got from above, you may or may not be off. So what the smart thing to do is to take your s value that you're squaring and go a little bit deeper than usual. So 5, 6, 5, 6, and go as deep as I did last time, right here, and square it. So if I take my sample standard deviation and square it, I will get this answer here, 184.0277553. And again, I'm just going to round to 2 decimal places, so 184.03. Now again, I said it's best to use the longer one instead of the one we used before for sample standard deviation, the rounded answer. And the reason for that is if we had done 13.57 squared, we would get pretty close to the answer, except it's going to be off by just a little bit, but that's enough to throw the whole thing off and give you a wrong answer. So when it comes to finding the sample variance or even the population variance, use a much longer approximation, about 5 or 6 decimals, when you're rounding to someone like 2 or 3. And finally, we have the population variance, and it is notated by sigma squared, which is the exact same thing we're going to do from the sample standard deviation when we squared it. It's just we're going to square the population standard deviation. And just like that, you want to make sure you use a long enough approximation. So we're going to do 12.789849 squared. So the variation, we're going to get 12.789849 squared. And we're going to get 163.58, round to 2 decimals, so 58. 163.58. And just to show you again, if we use the rounded answer and we square that, we would actually get the exact same answer. But that's the problem. You don't know. So when in doubt, just use a longer approximation just so you could be doubly sure that you won't have a rounding error somewhere later on.